Let's look at the domain of a function. We've worked on the domain by using the graph, and we just look at the x values on our graph, and then we could write that in interval notation. Well, what if we just have the function but we don't have the graph? Something like this. Let's say I had f of x equals 2x squared plus 3x plus 5. Now, as long as you don't have a denominator, you don't have a square root, then your domain is all real numbers. The way that you write that in interval notation is parentheses, negative infinity, comma, infinity, parentheses. So this also means all real numbers. Alright? So as long as you don't have a denominator or a radical, then we don't have a problem plugging anything in. So the domain is all real numbers. Now if we do have a denominator, let's say that I had 5 over x minus 3, and I wanted to figure out the domain. List the domain. Alright, when you have a fraction, you do not want to divide by 0. You don't want your denominator to equal 0. So the way you figure out what you need to leave out of your domain, or the restriction on your domain, remember, is by setting the denominator equal to 0. Now one like this, you can just probably look at it and tell. But you can still take the denominator, set it equal to 0, and solve if you can't tell what we do not want x to be. If x is equal to 3, then 3 minus 3 in the denominator is 0, and we can't divide by 0, so we need to leave that number out of our domain. The way that we do that, we don't just write out in words the domain is all real numbers except positive 3, even though, you know, if that's correct. But the way that we write that in interval notation, to leave a number out, we always start with negative infinity, so negative infinity until you get to a positive 3, and we put parentheses with it. That means don't include 3. If we were to put a bracket, that would mean include 3. But if we put parentheses, that means don't include 3, all the way up to 3, but not 3. And then we put a big U, that means union with, or and, 3 to positive infinity. And we always put parentheses with negative infinity and positive infinity because those are concepts, those aren't actually numbers. Alright, but this is how we would leave a positive 3 out of our domain. Negative infinity to the number, union with, from the number to infinity. So this is everything except 3. That's what that means. All real numbers except 3. Alright. So no matter what the denominator is, if you have a denominator, you need to figure out what would make that denominator equal to 0. Okay? Because that's restrictions on our domain. So let's say that we have f of x equals 3x minus 1 over x squared plus 4x plus 3. Now, it does not matter whether the numerator is equal to 0. This can be 0, that's okay. Because if the numerator is 0, then the whole thing is 0. Alright? So what we need to do is we need to take the denominator and figure out when will it equal 0. So set the denominator equal to 0. And solve this using any method that you know how to use. On one like this, I would suggest factoring because it will factor. So x plus 3 plus 1, right? That would give us a positive 3, and that would give us a 4x in the middle. Now set each factor equal to 0. So x plus 3 equals 0, x plus 1 equals 0. Solve for x. So x equals negative 3, x equals negative 1. So if x is a negative 3, or if x is a negative 1, then we will have a 0 in the denominator. And we can't divide by 0. So we need to write the domain and leave both of these numbers out. Alright, so the way we do that, domain equals, we start at negative infinity. Now think about it. If we were at negative infinity and we were moving to the right on a number line, we would first come to negative 3, right? So it's negative infinity to negative 3, parentheses, union with, parentheses, negative 3. Then after negative 3, as we got closer and closer to 0, we'd come to negative 1. So negative 3 to negative 1, parentheses, union with, now negative 1 to infinity. So by starting in, or by ending a parentheses and starting the next parentheses with a number, you leave it out of the domain. So this leaves out a negative 3, and this leaves out a negative 1. And I'll said something about a number line. I think about it in my mind like this. I'm always starting at negative infinity and I'm going to positive infinity. So I write down negative infinity first, and then I think about numbers, you know, as I get closer and closer to 0. Negative 5, negative 4, negative 3. It can't be this number. So I have to stop my parentheses there. Then I start my next parentheses at negative 3. Then I'd have negative 2, negative 1. Well, it can't be that, so I'd end my parentheses. Then start my parentheses again at negative 1. I got 0, 1, 2, and then it just goes on and on forever to infinity. Alright, so that's how we leave numbers out of our domain. Alright, let's see what happens if we have a square root. Let's say that my function was equal to the square root of 2x plus 8. And I want to figure out what can I plug in and get out real number answers. With radicals, with a square root, a cube root, a sixth root, an eighth root, you know, if the index here is even. For us to get real numbers out, we want what's under the radical to be greater than or equal to 0. As long as this radical, this square root, is not in the denominator, we just want what's underneath to be greater than or equal to 0. So you simply come to the side and write the inequality. 2x plus 8 needs to be greater than or equal to 0. Now solve this like an equation. Minus 8 minus 8. So 2x is greater than or equal to negative 8. Divided by 2, divided by 2. So x is greater than or equal to negative 4. Greater than or equal to negative 4. That's what we can plug in. So our domain, we don't start at negative infinity. We want greater than or equal to negative 4. So if you look at this number line up here, here's a negative 4. So we want to have negative 4 including negative 4, and then everything greater than negative 4. Everything to the right. So the way we write that is bracket, because we include negative 4, comma, infinity, parentheses. So the domain is from negative 4, including negative 4, to infinity. Okay. As long as the radical is in the numerator, there's no denominator, then we want it to be greater than or equal to 0. Now, if for some reason the radical is in the denominator, the only change we have is that it can't be equal to whatever. Because if this would have been in the denominator, I'm going to make a very similar problem. If this function would have been 1 over the square root of 2x plus 8, then the only difference is when I work this out, I don't want this under the radical to be equal to 0 because it's in the denominator. So instead of greater than or equal to 0, it'd just be 2x plus 8 is greater than 0. So at the very end, after I worked it out, I would have x is greater than negative 4, not equal to. So the only change in my domain would be that my domain is from negative 4, not including negative 4, to positive infinity. So do you see the difference from a radical being in the numerator or a radical being in the denominator? You just don't include whatever point. Now remember, and you may have to think back, because I'm sure some of you, when you saw me working this first inequality out, think back to when you were working these out in previous math classes. And you probably saw me come down here and I got a negative on the right side, so some of you were thinking, man, wasn't there something about a negative with inequalities? Well, if for some reason, and it wasn't, so I'm going to erase what I'm about to write down, so you don't have to write this down. But if this would have been a negative 2, and I would have had to divide by negative 2, when you divide by a negative with an inequality, you have to flip the sign. So you would flip this around. Let me work an example out where you have to divide by a negative to solve for the inequality. So then you'll have one of those in your notes. Alright, so let's say that I had f of x equals the square root of, let's say, 8 minus x. So I still want what's under the radical. It's in the numerator. I want what's under the radical to be greater than or equal to 0. So 8 minus x is greater than or equal to 0. Now let's solve for x. Move the 8 over, and I have negative x is greater than or equal to negative 8. Now I want to solve for x. So divide both sides by negative 1, because that's a negative x. When you divide an inequality by a negative, you flip the inequality sign. So instead of it being greater than or equal to, it becomes less than or equal to. And now that's 8. Alright. It may help you to think about this like it was on a number line to write it the interval notation. We want x to be less than or equal to 8. So if I was on a number line, think about the numbers less than or equal to 8. So less than are the numbers to the left of 8 on the number line. So if I wrote this in interval notation, I start on the left side. What number is out here that means negative numbers forever? It's not a number, but the concept is negative infinity, comma, until I get to 8. And since there was an equal to bar, you put a bracket. So this means all numbers less than or equal to 8. Alright. I want you to try a couple of these. So find the domain for these three functions. Take a couple minutes and work those out. Alright, so trying to figure out the domain of each of these functions. So for this first function, I have a denominator, so I need to set the denominator equal to 0. This tells me what will make my denominator equal to 0. So the easiest way to solve this is the square root property. Move the 16 over by adding 16 to both sides. Take the square root of both sides. X equals plus or minus 4. So that's what we do not want x to equal. We don't want it to equal a positive 4 or a negative 4. So the way we write that domain is from negative infinity to negative 4, union with negative 4 to positive 4, union with positive 4 to positive infinity. So that's how we would leave out a negative 4 and a positive 4. Those are our two restrictions. Alright, on this next function, I do not have a denominator, so I just want what's under the radical to be greater than or equal to 0. Alright, so solve for x. Add 9 to both sides. So 3x is greater than or equal to 9. Divide both sides by 3. So x is greater than or equal to 3. Greater than or equal to 3 would mean from 3, including 3, the greater than or equal to, including 3, and then greater than means to positive infinity. Parentheses with positive infinity or negative infinity. So the domain is from 3, including 3, to infinity. Means I can't plug in anything less than negative 3. If I did, I would start getting negative numbers under the radical. I don't want that. Alright, this last one here, I do have a denominator, and it so happens that the denominator has a radical. So I just need to figure out, I do not want this to be equal to 0. I want what's under the radical to be just greater than 0. It's under a radical, so it has to be greater than 0, not equal to, because we don't want to divide by 0. So I say 24 minus 3x is greater than 0. I don't put an equal sign, don't put an equal to sign, because I don't want the denominator to be 0. Alright, so move your 24 over, subtract 24 from both sides. So I have negative 3x is greater than negative 24. Divide both sides by negative 3. When you divide by a negative, you flip the inequality sign. So this is now x is less than, because we divided by a negative. Negative 24 divided by negative 3 is a positive 8. So x is less than 8. So the domain less than 8 is going to be from negative infinity to positive 8. Because it's less than 8. So 8 or less. Okay. Now let's take a look at the algebra of functions. And actually what we're about to do, you've already done probably, several hundred times in your life. It's just another way of writing it. If we have two functions, we can find the sum of those functions by simply saying f plus g of x, which means f of x plus g of x. So let's say I had two functions, f and g. If you see this notation right here, f plus g of x, that just means take the first function and add the second function. Most of the time you're just adding like terms, or adding terms together. So for example, let's say that f of x equals 2x plus 5 and g of x equals x squared plus 2x plus 1. If I wanted to find f plus g of x for these two functions, that just means add the two functions together. So I don't have an x squared in this other function, so it's just going to be 1x squared, and then 2x plus 2x is plus 4x, plus 5 plus 1 is plus 6. So you just, if it's a plus here, take the first function and add the second function. Combine like terms. Like I said, it's something, you know, you've added and subtracted and all that kind of stuff time and time again. This is just a way of saying, let's find the sum of the two functions. Alright, we can find the difference of two functions by writing the notation f minus g of x. That means f of x minus g of x. Now be careful with this when you subtract, because you're subtracting g of x. So no matter how many terms g of x has, you're subtracting each of those terms. So you might want to just put g of x in parentheses and then distribute the negative and simplify. So if I use these same two functions and I wanted to find the difference, I would say f minus g of x is equal to f of x, so 2x plus 5, minus g of x, x squared plus 2x plus 1. Then I would distribute the negative, so I'd have 2x plus 5 minus x squared minus 2x minus 1. Then I'd combine like terms. So I'd have negative x squared. Just so happens these x's cancel out. The negative 2x and the positive 2x. And then plus 5 and minus 1 is plus 4. So f minus g of x will be negative x squared plus 4. Adding functions, subtracting functions. Okay? Two more properties. We went over the sum, we went over the difference, now the product. If you have f times g of x, that means f of x times g of x. So if you see a f and a g beside each other, nothing between them of x, that means take f of x and multiply it times g of x. So if I did that here for these two same functions, if I wanted to find f times g of x, that would mean 2x plus 5 times x squared plus 2x plus 1. So take the first number and multiply that times everything in the parentheses, and then take the next number and multiply that times everything in parentheses, and then add the like terms. So let's see what we would have. 2x times x squared is 2x cubed. 2x times 2x is plus 4x squared. 2x times plus 1 is plus 2x. 5 times x squared is plus 5x squared. 5 times 2x is plus 10x. And 5 times 1 is 5. Combine like terms, and I would have 2x cubed plus 9x squared plus 12x and then plus 5. Alright, so f g of x means f times g of x. So f of x times g of x. And the last property of this algebra of functions we're going to cover is f over g of x. That's the quotient. So what does that mean? that means f of x over g of x. If we did that, we would have 2x plus 5 over x squared plus 2x plus 1. Alright, what if I took all 4 of these problems that I just worked out and I said state the domain? That means find the domain of your answer. Alright, look at this one right here, this first one, the sum. I'll do this in red. There's no denominator, there's no radical. So the domain for f plus g of x is all real numbers, negative infinity to positive infinity. Alright, look at the domain for the difference. There's no radical, there's no denominator. So the domain, negative infinity to positive infinity, all real numbers. Look at f times g. Look at the answer. No denominator, no radical. So the domain is all real numbers, negative infinity to positive infinity. Look at the quotient. Alright, now most of the times with a quotient, you're going to have to figure out what would make the denominator equal to 0. Okay? So, because we have a denominator. So set the denominator equal to 0 and see what would make it 0. If we factor this, we get x plus 1 equals 0. Now, it just so happened on this one I got the same factor here and here. So I only have to solve for it once. So I don't want x equal to -1. If x is -1, then this denominator is 0, and that's a problem. So the domain is going to be all real numbers except -1. Remember the way we leave out a -1? Say domain equals negative infinity to -1 union with -1 to positive infinity. So that leaves out a -1. All right. Now, let's take a look at composite functions. Composite functions is a way of taking two functions and figuring out an equation where we see what one function evaluated in the other function would give us. So, for example, let's say that f of x was equal to x plus 1, and g of x was equal to x squared. Okay, and I wanted to know what is, say, f of g of x. So what this right here means, f of g of x, means that I need to take my g of x and I need to plug it into every x in f. Okay? So another way of writing f of g of x is using this notation. F a little o g of x. So if you see this, it almost looks like the word fog. If you see this notation, this means take the second function, or take the g, whichever one the g is, and plug it into the f. This is read f of g of x. This is read f of g of x. So they're read the same way, and they mean the same. F of g of x means to take g of x and plug it into f for every x. So on this one, I take g of x, take this right here, and plug it into f for every x. Alright, there's only one x here, right? So I'll plug it in right there. So f of g of x, or f of g of x, is equal to x squared, and then I have a plus 1. So f of g of x equals x squared plus 1. Now there's another way, or another type of problem that could arise from this, from these two functions. The composition the other way. What if I wanted to find g of f of x? That means I need to take f of x and plug it in for every x in g of x. Another way of writing that is g, a small o, f of x. This means take the f function and plug it into the g function. Take the f function and plug it into the g function. G of f of x. G of f of x. So now, instead of taking the g and plugging it into the f, I'm taking the f and plugging it into the g. So I'm going to take this right here from the f, and I'm going to plug it in for every x in g. And when you plug something in, you always put it in parentheses. If you're squaring it or multiplying it times something, or there's a negative in front, you always put it in parentheses. So g of f of x is equal to x plus 1 squared. Alright, and what does that mean? That means x plus 1 times x plus 1, and then you need to FOIL that out. When you FOIL that out, you'll get x squared plus 2x plus 1. Alright, so we have two different types of functions we're looking at, and this is the composition of functions. f of g of x and g of f of x. Now, if my problem, instead of just having f of g of x or g of f of x for those two functions, if my problem would have had f of g of 5, what that means is find f of g of x and then plug in a 5 for every x. So up here where I found f of g of x, right here, now take that and plug in a 5. So this would be 5 squared plus 1, or 25 plus 1, which is 26. Alright, so let me work a few more examples on that. Let's say that my two functions were f of x equals 3x and g of x equals x minus 5. And I wanted to find f of g of x g of f of x, f of g of 2, and g of f of 2. So what I'm going to do is I'm going to first find f of g of x, then I'll find f of g of 2. Alright, now so f of g of x, to find that, remember, take the second letter. So I'm going to take the g and I'm going to plug it into the f. So all of this right here, x minus 5, and I'm going to plug it in right there for the 3. I mean for the x. And I have a 3 in front, so I need to put that in parentheses. So this is 3 times x minus 5, or 3x minus 15. Now, to find f of g of 2, take a 2 and plug it in for your x. So that's 3 times 2 minus 15, or 6 minus 15, which is negative 9. Alright. Now, g of f of x. That means take your f and plug it into your g. Here's our function f. We're going to take it and plug it into our g. So that's 3x minus 5. I took my 3x, plugged it in right there. So f of g of 2 means to just take a 2 and plug it in right there. So this is 3 times 2 minus 5. 6 minus 5, which is 1. Now another way that you can do this second step here, or this second two problems here, if you're good at mental math, what you could do in your mind is, if I want to evaluate a 2 into f of g, then take a 2 and plug it into g. That would be 2 minus 5 is negative 3. And then take that answer and plug it into f. So 3 times negative 3 is negative 9. So get the same answer. Same here. G of f, if you take the 2 and plug it into the f and get the answer, and then take that answer and plug into the g, we should get the same thing. So if I plug a 2 into the f, so that would be 6. Take that and plug it into the g. 6 minus 5 is 1. That is a positive 1. All right. Sometimes doing that mental math will be easier than actually finding f of g of x, because if you have quadratics with f and g, then f of g of x and g of f of x can be kind of long. All right. Let me do one more example. Let's say that my two functions were f of x equals 7x plus 1 and g of x equals 2x squared minus 9. I'm going to find f of g of x. I'm going to find g of f of x. Then I'm going to find f of g of 2 and g of f of 2. All right. So first, f of g of x. This means take the function g and plug it into f for every x. So here's g, this function right here. I'm going to take it and plug it into f for every x, which just happens to be this 1x right here. So that's 7 times 2x squared minus 9, or 14x squared minus 63. Now to find f of g of 2, I plug a 2 in for my x. I would plug it in the answer right here I got. Alright, so use your calculator. It's 14 times 2 squared, or 14 times 4, minus 63. Alright, I got negative 7. Alright. So now, let's find g of f of x. That means take the f function and plug it into the g. So I'm going to take all of this right here in my f function, and I'm going to plug it into the g. Right there. And when I plug that in, I am going to have to put that in parentheses because it's squared. So 2 times 7x plus 1 squared minus 9. Remember, we don't multiply in first. First, we have to square this. So you have to do what? FOIL it out. I'm going to write it up above here. Now, when you FOIL that out, first, so that's going to be 49x squared outer plus 7x inner plus 7x last plus 1. So this right here is 7x plus 1 squared. So 2 times 49x squared plus 14x plus 1 minus 9. Now distribute your 2. So that's 98x squared plus 28x plus 2 minus 9. or 98x squared plus 28x minus 7. And you put the 2 and the negative 9 together. Now to find g of f of 2, you take the 2 and you plug it into every x. Alright, so I'll use the calculator to do this real quick. That'll be 98 times 2 squared is 4, so 98 times 4, and then plus 28 times 2 is 56, so plus 56, and then don't forget minus 7. Alright, so I got 441. Now I could use the shortcut when working out this part right here if I wanted to. What's the shortcut? Take the 2 and plug it in up here. So that would be 14 plus 1 is 15. Then you have to come over here and plug in a 15. So 15 squared times 2 minus 9. And I get 441. I get the same answer. Okay? So that is composition of functions. So quick correction. Forgot the plus 1. Don't forget the plus 1. So that would be minus 62. So that will change this answer here. Instead of negative 7, it's going to be negative 8. Mm-hmm.